We just wanted to show you something interesting we saw in the satellite loop today. When you go to this particular page, it will show you the full disk. This is the view of the satellite goes west, which is geosynchronous orbit, 22,000 feet above the Earth. This one's over the equator, southeast of Hawaii. Pretty amazing that it can sense so far away in the northern latitudes. But right off the bat, you can see there are two tropical cyclones. There's Dora right there southeast of Hawaii, and the other one is Eugene off the Baja, Mexico. I'm going to choose the mesosector, which mesoscale 1. Right now it's positioned over the northern Rockies. And I'll use the mouse wheel to zoom in. And just wanted to let your eyes look for a feature that looks like a comma cloud. And this feature, as I zoom in more, and let me go up here and turn on the county shapefile. So add a map, go to counties, and now you can see Idaho County. I'm going to put this in motion. Sometimes it takes a while for it to load all the images and all the tiles. And it's currently loading all the tiles. As you can see, there's over 2,000 tiles that it's loading into the memory. It took a little while. There's 56 images that it was loading. But look at this feature south of Idaho County. It's kind of circulating in a cyclonic manner or a counterclockwise manner. This is a shortwave. This you may have read in our discussions, our AFDs, about short waves, or we might say upper wave, or vorticity maximum. And this feature can actually produce its own weather, and as you can see, it's producing clouds. And with it, there are regions of upward motion and downward motion, or areas of ascent. And those areas of ascent, it's bringing in warmer air and forcing it upwards. The warm air is buoyant. It wants to rise. It causes upward motion. You need to start moving the air upward to allow condensation to occur. It gets forced upwards. The moisture in the air starts to condense in the cloud as it cools to the dew point, as it gets saturated. These features can be the impetus for thunderstorm development. So today, this feature is going to be moving northeastward into an environment where it's heating up. You can see all the clear areas. That's where the sun's heating up. And by looking at the dew points, the observations, the dew points are in the 50s, which is pretty juicy for us this time of year. These thunderstorms are going to be able to produce a very high amounts of rainfall in a short amount of time. So another way to look at these features is by looking at the water vapor. And we're going to look at, let's just look at the mid-level water vapor level. And these different levels are sensitive to moisture at certain levels of the atmosphere. So this one, because of the color table that this is using, you can't really see that feature. So let's look at the lower level water vapor, and we'll speed that up. So you can sort of see that short wave. It's not very apparent in there. Let's look at the upper level water vapor. On our computers, on the AWIPS computer, we can actually change the color table, and that can actually accentuate the colors to where you can actually see the circulation a little better. But this one, you can't really see it very well. Let's look at the band 13, or the IR, the 10.3 micron that allows us to be able to sense the top of the clouds, the temperature. And generally the clouds that are cooling dramatically are the ones that are vertically, in the vertical, are developing very strong updrafts, and they're able to reach way up high towards the stratosphere. And in the stratosphere, we're talking, well below 0 Celsius. And these cloud top temperatures, the greens, are showing about minus 50 Celsius, which is really, really cold. That means that updraft is so strong it's able to penetrate the stratosphere temporarily as the anvil spreads out. And you can almost see not much movement to these storms southwest of Lolo Pass, and they're probably producing very heavy rainfall at this point. Another thing that you have to be aware of is that because the satellite is so far away, over the equator, southeast of Hawaii, it's looking at our region at an angle, and there's something called the parallax. And roughly, you almost have to take that feature that you're looking at and bring it south and west, approximately 7 miles, to account for that parallax. So it looks like those storms are over southern Valley County, but in actuality, they're right on the border, and the radar actually helps us to see. So we're going to look at the MRMS page, and the radar can really help us to fine-tune to see where those storms are actually developing and producing those heavy rainfall. So I'm going to zoom in, and you can see that these storms, and I'll put this in a loop, you can see the storms are forming over that higher terrain, and it's actually very good terrain for these storms to develop, because that southerly wind with the general cyclonic flow that we're having is able to hit the mountains and get force upward, so they actually are creating their own ascent, their own upward motion. And you can see these guys are not even really moving at all. So if we look at the rainfall intensities, the rates, these rates are showing 2-inch per hour rates right there along the border. So going back to this, let's go back to the geocolor. Just wanted to show you an example of what a shortwave looks like, and then also how, as it moves into a region of instability where it's been heating up by the sun, it can be an impetus for severe weather or flooding. And honestly, this shortwave kind of looks like what happened yesterday, August 5th, where we had a shortwave move north and eastward, and we actually had flash flooding, many landslides that occurred along the Salmon River Road west of North Fork. It's going to be interesting to see what type of storms form today as we head into the mid to late afternoon hours. So I guess precautions that you can take if you are recreating in southern Idaho County and Lemhi County are: be aware of potential for flash flooding today, and you may want to possibly alter your plans, because some of these backcountry roads, there's only like a few ways to get to a location, and you may get cut off if we have landslides or there's a washout, and you may not be able to pass through.